Hello everyone, welcome back. In this video I'm going to show you how to set up a killer configuration for your project, which is the most important part of every project. In order to do so, we should open the KL. We have already created a project. If you don't know how to create a project, you should watch my last video. The link is here. And alright, we go to include, new, and add a header file, main.h. And I created this header file because I want to add all my includes here so they don't occupy my main.c. Okay, let's do it. The first include would be STM32 xx.h, and the next one std.h, so I can use a boolean variable. Next one would be stdio.h, so maybe I want to use printf in my project. Now I go to the main.c and just include main.h, and all of these headers now are available in my main.c. Okay, it's time to go to register, which is my project folder, and create a new folder and call it peripheral, because I'm going to set up all the peripherals available in STM. Here include and source folder. Now go back to the Cube IDE and press F5, properties. I wanna add the path, so go to path and symbol, add file system, peripheral, include, and source location, and that's it. Go to peripheral, include, new, header file, and I'm going to teach you a color configuration. So this would be color.h and source file for it, color.c. Let's build it to see if we have any problem or not. Alright, no errors, no warning. Alright, in the color.h I should include main.h, so I can use all the headers here. Then our function would be void clock config void, and copy it, go to color.c here and include in color.h and paste the function here. Alright, I have provided all the value you need for your color configuration. In order to get these for your device, you should go to reference manual or simply go to CubeMX, File, New Project, and select your board. Mine is 29 Discovery. Start. And after you connected all the pins for your project, go to System Core, RCC, Prescaler, Crystal Ceramic. Then go to plug configuration. Here you can see all the details. APB1, APB2, HSE. All you need here is here. Alright. And the first step is to turn on the HSE and wait for HSE to be ready. We should go to reference manual, reset and control register, RCC register, RCC control register, and look for HSE. 16-bit is HSE. So let's go to 16-bit. In order to enable the HSE, you should put 1 in 16-bit. As we here, put 1 in 16-bit. And how we can wait for HSE to be ready? 17-bit. We should write 1 in 17-bit. By while we will wait until the HSE is ready. And next step is to enable power clock and voltage regulator. In order to do that, we should go to RCC APB1 enable register. So go to reference manual, seek out the APB1 enable register, and 28 power enable. So let's go to 28 power interface clock enable. In order to enable it, we should put 1 in 28. 1 in 28. For voltage regulator, we should go to power control register. And let's see where the power is. And power control. Here we have power control register 1 and 2. You should choose according to your device. And alright, 14 and 15. Let's scroll down. And here it should be in reset value. You should put 3 in 14, or you can put 1 in 14 and 1 in 15. As we did here, you can put 1 in 14 and 1 in 15, or only just put 3 in 40, which means 1 and 1. And alright, remember PLLP should be 0, so the value would be 2. Why? Because let's go to RC register and find out PLLP 16. If we want our value to be 2, it should be 0. For other PLL, you should write just the value. For PLLP, you should follow the instruction. If you want the value to be 4, you should put 1. And the next parameter is flash latency and its setting. Before going to reference manual, we should go to CubeMX, RCC, system parameter. And as you can see, we have 3 parameters here: instruction cache, buffer, and data cache, and flash latency. So let's go to reference manual, go to embedded flash memory, flash interface register, flash access control. Here we are, data cache, instruction cache, and buffer. They should be enabled. 8, 9, and 10. 8, 9, and 10. And latency should be 2. You can put 2, 3, 4 according to your project. I prefer 3. Alright, AHP, APB1, and APB2. You should go to CubeMX, color configuration, AHP, prescaler, APB1, and APB2. This can be 2, 4, 8 according to your project. So let's go to RCC and color configuration. Open the reference manual and RCC and color configuration register. Let's scroll down. This is our APB2. According to your project, you should choose 2, 4, 8. If you put 1, which means your AHP clock is not divided. It's true for APB1 as well. Let's see AHP prescalers here. Like others, you should choose 2, 4, 8 according to your project and write them here. Alright, let's open the declaration. And as you can see, if it's divided by 1, which means it's not divided. And you can also put this value and instead of this, it's the same. And the next step is a little bit challenging. You should configure the main PLL. Let's go to RCC PLL configuration. And RCC PLL configuration. Let's scroll down. Our PLL M starts from 0 to 5. 0 to 5. And PLL-N starts from 6 to 14. 6 to 14. And PLL-P starts from 16 to 17. So 16 to 17. And then go to 22, which is main PLL. In order to enable it, you should put 1 to 22. Actually, this is not enabled. You should choose HSE or HSI. In my project, I choose HSE, so I put 1 in 22, as we did here. And after that, we should enable the PLL and wait for flag to be ready. So we should go to RCC control register. Let's go to reference manual, RCC control register, PLL enable and PLL ready, 24 and 25. In order to enable the PLL, you should put 1 in 24, as we did here. And in order to wait for PLL flag to be ready, we should put this code here. Let's go to reference manual, 25, PLL ready. Should put 1 in 25 bit in order to be ready. And by while, we will wait until the flag is ready. And after that, we should select the clock source and wait to be set. In order to do that, we should go to RCC clock configuration register. RCC and clock configuration register 1 and 2. Let's scroll down. Our system clock should be PLL, so we write 2 in 1. Actually in 0. As with here, 2 in 0. and we should wait to be set. While we will wait, and by putting 2 in 2, we will wait for a status to be set. And that's all you have to do. Let's build it to see if we have any problem. And we have 2 errors. Let's see what that is. Alright, I find out the problem. Here I forgot this. Let's build it again. Alright, no errors, no warning, which means we have configured our clock successfully. Alright, that's it. That's how you configure your clock without using HAL library. Only use register. If you have any question, you should write it on the comment section below, and I will answer it quickly. Have fun.